There are four methods to calculate price elasticity of demand. First one is the percentage method, which we have already discussed, and related sums also we have solved. Then second one is the arc method. Arc method. What is arc method? Arc method measures the average elasticity. It measures the average elasticity. Average elasticity. Average elasticity. What is average elasticity? You have studied that demand curve is downward sloping. Demand curve is downward sloping. This is one of the slopes of the demand curve. One of the slopes of demand curve, say D1, the demand curve, and another slope. This is downward sloping, and another slope of demand curve also you have studied. This one. This is also BB1. BB1. So both are the demand curves. Both are downward sloping demand curve. Both are demand curves and both are downward sloping. So by the law of demand curve is downward sloping because price and quantity of demand moves in opposite direction. So this is demand curve, downward sloping. This is also downward sloping. So what are the differences between these two? This is a straight line and this is a convex shape. So this is convex UNVX, convex shape demand curve, and this is straight line demand curve. So this is also downward sloping and this is also downward sloping. So since demand curve is downward sloping, so both are the demand curve. But in case of percentage method or proportionate method, you have calculated the price elasticity delta P equal to delta Q by delta P into P by Q. Now you see, if we measure here, so suppose this is Q1, this is Q2, and this is P1 and P2. So you know that delta P is change in price, so P1 minus P2, and delta Q is change in quantity Q1, Q2, in this way, Q1, P2, and original price and original quantity you will get from here, and you will get the value of elasticity, which you have calculated through different sums. So here there is no problem if the demand curve is downward sloping. If the demand curve is downward sloping, straight line demand curve, there is no problem. You can easily calculate. You have learned the methods also. You can easily calculate the demand curve. Elasticity of demand. But if the demand curve is convex shape demand curve, then here you are not getting straight line. So how will you measure the elasticity of demand? So for that, to measure the elasticity of demand for a convex shaped curve, you need to apply the arc method. Which will measure the average elasticity. So let me draw this curve figure. Price per unit original O, and this is quantity demand say Q. Now the demand curve is here. The demand curve is convex shape demand curve. So this is convex shape demand curve BD1. BD1 is the convex shape demand curve. And in case of convex shape demand curve, since it's not a straight line, so the percentage method cannot be applied. For the particular method is the arc method. Arc method measures the average elasticity. How the average elasticity is measured? What is average? Suppose there are three brothers and sisters in your family. Your father has given you 7 oranges or 100 oranges brought by your father, and those are distributed not evenly. Uneven distribution has been made. Somebody has got 7, somebody has got 20, somebody has got 30, 40, like this. So if I asked what is the average number of oranges you have got, so what will you do? You will add the number of oranges all of your brothers and sisters have got divided by the number of brothers and sisters you have. So like this you calculate the average number of oranges you have got. Here also average means number of points. So here first we have to draw the straight line. How will you draw the straight line? Any 2 points you draw derive on the demand curve 2 points, and we connect those 2 points. Now see, this is called chord, chord. So it is actually the focal chord which connects 2 points on the demand curve. But that must be the convex shape demand curve. 2 points on the demand curve, and to join this demand curve, those 2 points on the demand curve is called chord, focal chord. So, since it is not possible to measure elasticity of demand of such type of convex shape, the chord which you have drawn is a straight line. But here if you point any, or the consumer choices is pointed on the straight line, so on that particular line your elasticity will be measured. That will be the elasticity of this straight line, not this one. So that is why average is taken. Say corresponding price here, corresponding price is this one, say P1, and the corresponding quantity is here Q1, and this is P2 and Q2. Now, like straight line demand curve, P1, P2, Q1, Q2, you have plotted. Now change in price, delta P, you will be able to measure Q1 by minus P2, and delta Q also you will get from here Q1 minus Q2. But how will you measure the average? You will measure of price and quantity. So in case of the elasticity formula, you have known E equal to delta Q by delta P into P by Q. So that delta Q is this one and delta P is this one. There is no problem in this part, delta Q by delta P. But problem arises here, P by Q. This is initial price and initial quantity. Instead of initial price and initial quantity, you have put here average price and average quantity. So what will be the average price? The average price will be P1 plus P2 by 2, because 2 points like your 2 brothers sisters. So 2 points P1 and P2 divided by 2, and average quantity will be Q1 plus Q2 by 2. Q1 plus Q2 by 2. Now, if you derive this formula of arc method, EP is equal to delta Q by delta P into P1 plus P2 divided by 2 whole divided by Q1 plus Q2 divided by 2. So from here to and here to cancel. So delta Q by delta P into P1 plus P2 divided by P1 plus Q2. This becomes the formula of arc method of measuring elasticity of demand when the demand curve is convex shaped. So how will you define the arc method? Arc method measures the average elasticity. It refers to the change in quantity demand. Refers to the change in quantity demand due to very small due to change in due change in its in its price. Change in its price. So change in quantity 1 due to change in its price. In case of percentage method or proportional method, you have defined is percentage change in quantity 1 due to percentage change in its price. But here the difference is change in quantity 1 due to change in its price. So it measures the average elasticity. It measures the average elasticity. So this how this average is taken. Average is taken drawing a straight line between the points on the convex shaped demand curve. And once you add those two points on the convex shaped demand curve, the line which you get is the straight line. It's called chord. So chord is a straight line which connects two points on the demand curve, provided the demand curve is convex shaped. If the demand curve is straight line, then the question does not arise to draw the chord, because their chord and the demand curve will fall on the same, will coincide to each other. So chord and demand curve will be same. So question does not arise to draw chord if the demand curve is straight line. Since the demand curve is convex shape, so we have drawn two points on the demand curve, and those two points we have joined, we get a straight line that is called chord. So based on the chord, we will be measuring the average price elasticity, average elasticity of demand, that average based upon the chord. So delta Q we get from here P1 minus P2 or P2 minus P1. Delta Q is equal to P1 minus P2 or P2 minus P1, and average price P1 plus P2 by 2, because 2 points are there, 2 prices are there, P1 and P2, and average quantity also Q1 plus Q2 by 2. So simply here in plot this like this one, this is for straight line, like this one, delta Q by delta P into, instead of P, P1 plus P2 by 2, P1 divided by Q1 plus P2 by 2. Q1 plus Q2 by 2. So the formula becomes cancelling this 2 and these 2, delta Q by delta P into Q1 plus Q2 by Q1 plus Q2, Q1 plus Q2. So this is the formula. This is the formula of arc method of measuring price elasticity of demand, provided the demand curve is convex shaped. Tell me whether you understood or not. Have you understood all? Hello? Hello?
Yes, sir.
Yes, sir.
Okay. So then I am moving to
Yes, sir.
Okay, good. So I am moving to total outlay method. This is the third method of measuring
Sir.
elasticity of demand.
Sir.
Yes.
Sir, can you repeat that formula?
This one.
Can you understand,
Yes,
sir?
sir.
Actually, we're not able to
Sir, the
understand.
board is not yes clearly visible now.
Clear,
Sir, can you use
visible.
a dark color marker? Yes, sir. Black color marker is free.
Now is the board clear?
No, sir.
So perhaps black marker. Okay. Wherever you will be having problem, you ask me so that I can understand. I don't know. And green idea. Green.
Can you please explain once again?
Yes, I will.
Thank you, sir.
I will. লেখা হচ্ছে খালি রিলেশন is the board visual now? Board
Yes,
is
sir.
visual?
Yes, sir.
Yes, sir.
Now also visible or not?
Visible.
Visible.
Visible, sir.
Visual. Okay.
Arc method. Okay.
Yes, arc method. So arc method measures the average elasticity. Average elasticity. Average elasticity. Elasticity. Average elasticity. How does it different from the other method, first method? In case of first method, you have seen proportionate change in quantity demand due to proportionate change in price of that particular commodity. Price of the particular commodity. So there, you derive the formula U equal to delta Q by delta P into P by Q in the P by Q. Now here in our method, since it measures average elasticity, so the demand curve should not be straight line. The demand curve must be convex shape demand curve, because you have seen two types of demand curve, different shapes, but both are straight line, both are downward sloping. This is one demand curve downward sloping, and this is also another demand curve downward sloping. So for this, there are many methods. Total. This is white method. You can measure here. You can measure through percentage method also. Total outlay is different. And but for this, there is no prescribed. There is no this white method and percentage method cannot be applied because it's a convex shape demand curve. Convex shape demand curve. For this, the method which is applied is called the arc method. It's called the arc method. It measures the elasticity of demand if the demand curve is convex shape. So let's draw the convex shape demand curve. D1 convex shape demand curve. This is price per unit and this is quantity demand. Now you see, since it's a convex shape demand curve, it's not a straight line like this. So here it is difficult to measure the elasticity of demand unless you get the straight line curve or straight line. So to get straight line, you need to find out the consumer choice on the same demand curve. After getting the consumer choice at least in 2 points, you derive a line, straight line. This straight line is what? This is called chord, C-H-O-R-D, chord. So now you have got a straight line. That straight line, based upon this straight line, referring to this convex demand curve, based upon this straight line, you will measure the elasticity of demand. So here at this point, the respective price is P1, and the respective quantity is Q1. And here the respective quantity is Q2, and here the respective price is P2. Now you see, two prices you have got P1, P2, two quantities also you have got Q1, Q2. And the formula of price elasticity, you know, delta Q by delta P. So what is delta P here? Delta P is, you know, Q1 minus P2. While solving the formula, mathematical problem also you say. And delta Q is what? Delta Q is Q1 minus Q2. After that there is no problem. But since it measures the average elasticity, so here in this case, this P was the initial price and this was the initial quantity. So initial price and quantity will not appear here. Here average prices and average quantity will appear here. So from here you calculate the average price. Average price is what? P1 plus P2 by 2. This is a formula of calculation of average. There are two prices P1 and P2, and since two prices divided by 2. And the average quantity is what? This is Q1 plus Q2 by 2. Q1 plus Q2 by 2. So in case of the formula of elasticity of demand, your formula was delta P by delta Q. So here it will be same as delta Q by delta P, because you can calculate delta P. And here instead of initial price, this will be average price P1 plus P2 divided by 2, whole divided by Q1 plus Q2 divided by 2. So is equal to delta Q by delta P into P1 plus P2 divided by Q1 plus Q2. This becomes your formula of measuring the average elasticity of demand or the elasticity of demand by arc method when the demand curve is convex shaped. When the demand curve is convex shaped. Clear or not?
Yes, sir. Clear.
Yes,
So
sir.
in case of convex demand curve, this will be the formula by the arc method. All of you are clear? Those of you asked me that it was not clear, asked me to repeat once again.
Yes, sir.
Okay, all of you respond those who asked. Now, let me move to the next method of measuring elasticity of demand, price elasticity of demand. Price elasticity of demand, there are 4 methods I said. Price elasticity, 4 methods I said. One is percentage method. Percentage method. Second one is arc method. Arc method. Third one is total outlay method. Total outlay method. And fourth one is point method. Out of this already you have learned percentage method and arc method. So now we will discuss the total outlay method. Total outlay method. Outlay is actually the expenses the particular individual incurs while spending. So total expenses have to be calculated. Expenses have to be calculated. Suppose per unit price, you know this demand curve is derived based upon the different combinations of price and quantity. So here we will be writing one hypothetical demand schedule stating different price and quantity combinations. Say price per unit, price per unit, price per unit is one. Then quantity demand per unit, and then total outlay we will calculate. Say price is per unit say 9. Here you write serial number 1, 2, 3, 4, 9, 8, 7, 6, 5, 5, 4, 4, 9, 8, 7, 6, 5, 4, 3, 4, 4, 5, 6, 6, 6, 7, 8. So in serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, and quantity 1, 20, 30, 40, 50, 60, 70, 80, 90. Those are the quantity one. Quantity one. It's a hypothetical schedule to show you, to make your concept clear. This schedule is being considered here only. So here, for example, per unit price of say Dettol, per unit price of Dettol. So when per unit, say per 50 ml or per 100 ml of Dettol price is rupees 9, 20 pieces of Dettol were sold in the market. were sold in the market. When the market price of Dettol per 100 ml is rupees 9, then 20 pieces, 20 units of 100 ml bottles of Dettol were sold in the market. When price reduces to 8 rupees, then quantity demand increases by the law of demand. So then 30 units, 30 numbers of bottles of Dettol are sold in the market. Again reduced to 7 rupees, again it has increased to 30 units. Again reduced to 6 rupees, again it has increased to 50 units. Again reduced to 5 rupees, increased to 60 units. Reduced to 4 rupees, increased to 70 units. It reduced to 3 rupees, increased to 80 units. Reduced to 2 rupees, increased to 90 units. Now, per unit price per bottle per pack of Dettol is rupees 9. So 20 bottles are sold in the market. So altogether in the market, total customers' expenses with the total outlay is equal to 9 into 20 is equal to 180. 180 rupees in units. 8 into 30. 8 into 30, how much? It is 240. 4 into 70, it is 280. It is not required to show this part. Just to make you understand, I have said. 6 into 50 is what? 300. 5 into 60 is what? 300. 4 into 70 is what? 280. 3 into 80 is what? 240. 2 into 90 is what? 180. If you look, the total outlay means total expenses in the market or the revenue earned by the shopkeeper or the producer, whoever. So is multiplication of per unit price and the units sold or purchased by the consumers. So it is 180. If we look the nature of the outlay schedule, here you will find one. This is another type. This is another type. What do you find here? What do you find here? This is increasing, remains same, and this is decreasing nature. Decreasing nature. So, in this case, when total outlay increases, 180 to 240 to 280, total outlay increases due to fall in price. Total outlay increases due to fall in price. Then price elasticity demand is greater than unity. Means unit value 1 greater than 1. Here if you see, here the total outlay 300 and 300 remain same. There is no changes, remain same. But due to fall in price of the commodity, so here total outlay remains same due to fall in price of the commodity. So if total outlay remains same due to fall in price of the commodity, then price elasticity is equal to 1 or unity. Price elasticity is equal to unit value or 1. And here you see total outlay decreases 280 to 240 to 180 decreases due to fall in price of the commodity. So total outlay decreases due to fall in price of the commodity. When total outlay decreases due to fall in price of the commodity, then price elasticity is less than 1. So when total outlay increases due to fall in price of the commodity, then elasticity is greater than unity or greater than unit elasticity. Unit elasticity. This unit is what? Unit is 1. Unit value is equal to 1. Unit value. Unit more than unitary elasticity, greater than 1. Greater than unity. And here total outlay remains same due to fall in price of the commodity, So it is called unitary elastic because it is equal to the unit value is 1. Unit value is 1. That is why it is unitary elasticity. And when total outlay decreases due to fall in price of the commodity, then is less than unity or less than unitary elasticity or less than 1, the value of elasticity. Now you may ask question, where from we are getting this value greater than unity, equal to unity and less than 1? What is the basis that this is greater than 1, this is equal to 1 and this is less than 1? The basis is that this is actually what happened. This is the market research. This is the research findings of Professor Marshall. Marshall is one of the economists who was propounded this total outlay method. So from this research finding, it has been seen that when total outlay decreases, total outlay increases due to fall in price of the commodity, price elasticity of demand is greater than unity or greater than 1. When it remains same due to fall in price of the commodity, the total outlay, elasticity, price elasticity, unitary value is greater equal to 1. That is why it is called unitary elasticity or unit elasticity of demand. And when price elasticity, total outlay decreases due to fall in price of the commodity, then it is less than 1 or less than unity. So changes takes place in total outlay, sometimes increasing, sometimes equal, sometimes decreasing, but always price fall. Now I like to mention one more thing here. In the examination, it comes sometimes. If it comes in the examination, you need to remember this particular formula. Otherwise, a particular this schedule. Otherwise, you may not be able to get this result. So that is why always I would suggest to memorize this to show the total outlay method in the examination. Otherwise, sometimes you may take this schedule is increasing and this is decreasing. Same result will be followed, but you will be in difficult position to conclude here. That is why you need to remember. But this 9 into 20, 8 into 30 is not necessary to show here. You may not show this, but this has this one. This is about the total outlay method. If you find the total outlay increases due to fall in price of the commodity, directly your conclusion will be greater than 1. If you find in any situation the total outlay remains same due to fall in price of the commodity, then your conclusion would be equal to 1. And if you find the total outlay is decreasing due to fall in price of the commodity, then your conclusion will be less than 1. So this is about the total outlay method of measuring price elasticity of demand. Tell me now, clear or not? Hello?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir. Yeah.
Good. So, total outlay method also discussed. Then the method which we will be discussing is whatever. The method which we will be discussing is point method. Point method of measuring elasticity of demand.
What's a point method?
Yes, point method.
And what is the first one? It is not visible actually.
I am making small because you know it is percentage method.
Sorry, sir.
Percentage method.
Okay.
point 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 method. So point method measures the elasticity of demand on different points of the same demand curve. Point method measures the elasticity of demand on different points on the same demand curve. If the demand curve is straight line demand curve. Let me draw the demand curve, straight line demand curve. Straight line demand curve. This is price per unit and this is quantity demand Q. Now the demand curve, say the demand curve D1 is the demand curve. So here it's a straight line demand curve. In this demand curve, we will measure elasticity of demand on different points. Point method measures the quantity demand due to very small proportionate change in price of the same commodity. So change in quantity demand due to change in very small proportionate change in price. So the change in price is very small proportionate change, but quantity demand will change. So this is denoted by EP. EP equal to lower segment of the demand curve, segment divided by upper segment of the demand curve. Now,
Sir, can you repeat?
This point method measures the elasticity of demand on various points on the same demand curve. It measures the quantity demand, change in quantity demand due to very small proportionate change in its own price. It is derived by the formula lower segment of the demand curve divided by upper segment of the demand curve. So wherefore this formula has been derived, there is long mathematical formula deduction to derive the formula of point method. This is not required for you. That's why this derivation I am not showing you. You need to remember the formula only. Lower segment of the demand curve by the upper divided by the upper segment of the demand curve. Now applying this formula, we will measure the price elasticity by point method. Suppose this is a point, for example, which is the midpoint of the demand curve. Suppose the demand curve is DD1, and A is a point. This is the midpoint of DD1. Now, at this point, if we measure the elasticity of demand, lower segment by upper segment, which one is lower segment? AD1 is the lower segment and BA is the upper segment. So lower segment is AD1 AD1 and upper segment is AD1 and upper segment is AD. You are clear or not?
So can you explain again?
Yes. The formula of price elasticity of demand by point method is lower segment of the demand curve, DD curve, and upper segment of divided by upper segment of DD curve. Okay. So the demand curve is DD1. So we want to, since point method measures the elasticity of demand on various points on the same demand curve. So A is a point which is the midpoint of DD1. A is the midpoint of DD1. This is the straight line and A is the middle value, midpoint. Now, since we want to measure elasticity at point A, so lower segment is AD1, this is lower segment, and upper segment is AD. Are you clear?
So that
Yes,
is
sir.
the upper segment.
Yes, this side is upper one, this is lower one.
Okay.
So lower part is AD1 and upper part is AD. Now, since it is a midpoint, suppose the straight line, this is a straight line, this straight line is 6 meter long, for example, 6 meter, B1. This straight line is 6 meter, like this. And A is the middle point. So, what will be the length of this side and what will be the length of this side?
Both are same 3.
So, this is 3 meter and this is also 3 meter. Clear?
Yes.
So that means AD1 is equal to AD. AD1 is equal to AD.
Yes, sir.
Understood? Similarly, here also, since this is the midpoint, so this value is equal to this value.
Yes, sir.
So is equal to 1 as AD1 equal to AD. Understood?
Yes, sir.
Yes, sir.
Okay. So elasticity of demand at point A is equal to 1. You can remember, I think that in case of total outlay method, I said the value of elasticity is equal to 1. So this is value of elasticity is equal to 1. Value of elasticity is equal to 1 at the midpoint of the straight line demand curve. Now, suppose at this point we are interested to calculate elasticity of demand. At this point, which is the lower end, lower end of the demand curve. Say, if we want to measure elasticity of demand at D1, then what will be the lower value, what will be the upper value? What is the lower part, what is the upper part? Let's see who can answer.
So can you repeat the question again?
Here, when I asked the lower part, you said AD1 is the lower part, right side. And this is upper part AD. You are very much right. So forget about A we have already solved, calculated. Now we are interested to calculate elasticity at D1. So now here numerator will be the lower part, denominator will be the upper part. So what is the lower value here? Lower part is how much? Aditi. Lower part is how much?
Yes, sir.
Lower part is how much?
Hello.
Hello. Lower part is how much? What is the value of lower segment? Lower segment is real 0
Yes, sir. Z.
and
Uh,
upper segment is DD1 whole straight line demand curve.
yes.
0 by something is what? 0 by
Hello.
something is what? 0 by 5 is how much?
0.
0
Sir,
by
0.
0 by 5
0,
is
sir.
okay.
0.
So 0 by something is
0.
equal to 0.
0, sir.
So equal to 0. So that is at the lower part of the demand curve, lower end of the demand curve, EP is equal to 0. EP equal to 0. Now, if we want to measure here at the top of the demand curve, what will be the value? First, you need to find out the upper part, lower part, then upper part. Lower part is what? Total demand curve, right side, PD1, and upper part is 0.
0.
0. So, something by 0 is how much? Say 5 by 0, 7 by 0. What is the value? What is the value?
5 by 0, 5.
Is equal
0.
to huh?
DD1.
How much? Equal to infinity. Is equal to infinity, undefined. So at the top of the demand curve, the value of elasticity is equal to unity. That's it. So এইগুলো ঠিক লেখা হচ্ছে না। If equal to infinity at this point, at the top of the demand curve, is undefined top of the demand curve. Now, suppose if we want to measure anywhere in this range, then you will see, suppose here is 1 point, this is 1 point, like this. If you measure here at this point or at this point, so if you measure here, this is the lower part and this is the upper part. And if you measure here, this is the lower part, this is the upper part. Wherever you measure in between this range, the lower part will always be lesser than the upper part. So suppose out of 6, say total length for example is 6 meter. Total is 6 meter. Out of 6 meter, this lower part is for example 2 meters. And upper part is 4. Or lower part is 1 meter, upper part is 5. So whatever may be the value, lower by upper is say 1 by 2 equal to 0.5. Or here 1 by 5 equal to 0.2, like this value. Whatever the value you get, you will always get the elasticity is less than 1. And here in this range, wherever you measure, suppose here or here or here, anywhere you measure, lower part will always be greater than the upper part. Since lower part is greater than upper part, here the value of elasticity will be greater than 1. So you see here on different points of the elasticity of the band, we are getting different value. Through the point method of elasticity of demand. Point method of elasticity of demand. We can measure the elasticity of demand on different points on the demand curve, and those are having the different values. say here from at this point it is 0, at this point it is equal to infinity. Therefore, the value of elasticity lies in between. The value of elasticity lies in between 0 to infinity, 0 to infinity, 0 to infinity. This is the range of elasticity of demand. Very important for MCQ. The range of elasticity of demand 0 to infinity. It's not 1 to infinity, 0 to infinity. It is either 0 or greater than 0 or it is infinity or less than infinity. We will not get the value of elasticity minus value. The minus which appears, you have seen while calculating the mathematical problems, this is just symbolic to show the price and quantity demand moves opposite direction. That is why even if you get it equal to minus 0.5 or it equal to minus 0.7, minus 0.7 or it equal to minus 1.5. You cannot express it. The value is minus 0.5. Value is equal to 0.5. This negative symbol we will not consider. It is just symbolic to show the difference, to show the movement of price and quantity demand in opposite direction. In opposite direction. In opposite direction. So by point method we can measure. By point method we can measure the elasticity of demand on different points of the same demand curve. On the same demand curve. Last class I said there are some commodities like life-saving drug. Life-saving drug. Whatever may be the price of the life-saving drug, but there will be definite quantity demand because it is purchased as per the prescription of the doctor, or there is no other substitute except that product. That is why the elasticity of demand for such type of product is equal to 0. Whatever may be the price, quantity demand do not respond. That is why for such type of case, you will get the demand curve is parallel to the vertical axis. Price is changing, but quantity demand is not changing. It remains same. This type of another example I can for this such type of car. Another example I can give you salt. Whatever may be the price of salt may be 20 rupees, 30 rupees, 40 rupees, but you need to purchase 1 kilogram of salt per week. That will not be changed. So price changes 20, 30, 40, 50, but quantity demand for salt for your family is 1 kilogram per week. That remains same. That is why price elasticity is equal to 0. Price elasticity is equal to 0 here. But in case of perfect competition, you will find the next chapter when I shall be teaching the market chapter. You will find the elasticity of demand is equal to infinity. Perfectly elastic. That time the demand curve will be parallel to the horizontal axis. Because it is infinitely, it is perfectly elastic or infinitely elastic. Here market demand, market equilibrium, price of commodity are determined by the market forces that demand and supply curve. So no other force here act or react upon this determination of price and quantity demand. So here you will find such type of demand curve, and other type of demand curves you will find for luxurious commodities, for necessity, for regular normal commodities, etc. This is about the point method. So all those 4 methods of demand curve I have discussed, measuring the elasticity of demand. The thing which left to discuss are the income elasticity of demand and the cross elasticity of demand, which I shall discuss in the next class, and that will complete your total demand chapter. But supply chapter is also included. That will take only 1 class to discuss that I shall discuss. So one more thing I would like to tell you that